Today on AI News, I'm going to break down Google DeepMind's four newest breakthroughs with Gemini Robotics 1.5, plus watch to the end to see what these different robots can now do in the real world as a direct result using this new level of AI thinking and reasoning. But first, we need to understand the foundation here. That's Gemini Robotics 1.5 and Gemini Robotics ER 1.5. So Gemini Robotics 1.5 is the core model. It's designed to understand and execute on complex instructions within physical environments, whereas Gemini Robotics ER 1.5, or environmental reasoning, this takes it a step further by specifically enhancing the model's ability to interpret and reason about its surroundings with unprecedented detail. And together, they form a team of AIs that work to push the boundaries of robot autonomy and intelligence. And both of them leverage the capabilities of Gemini 1.5 Pro, bringing its huge context window of over 1 million tokens and its multimodal reasoning directly to the challenging domain of real-world robotics. And here's what it means. Robots can now process way more information, including long-format videos, sensor data, and detailed instructions, as well as make far more nuanced decisions than ever before. Basically, you're witnessing robots moving from using pre-programmed movements to using intelligent, adaptive physical agents to finally enable the following four breakthroughs, with number four being the use of agents for physical tasks. See, Gemini Robotics 1.5 and ER 1.5 can now go beyond simple command execution and enter into genuine problem solving. Just think about it. Before, robots were mostly limited by explicit programming for every conceivable scenario. Even if a task deviated slightly from its predefined parameters, the robot would face challenges. But these new models are designed to interpret high-level, natural language instructions and then just break them down into actionable steps. Imagine telling a robot, prepare a simple meal, and instead of needing a step-by-step cooking guide programmed in, the robot just uses Gemini Robotics to reason about what simple meal means in this context, identify available ingredients, plan a sequence of actions like get a pan, turn on the stove, chop vegetables, etc., and then execute on them. This is all about understanding intent rather than just keywords. Plus, this agentic reasoning extends to error recovery as well. If the robot encounters an unexpected obstacle, like an item that it needs is missing or it's in an unusual spot, it doesn't just stop. Instead, it can reassess the situation, update its internal plans, and attempt to find an alternative solution or even ask for clarification in a human-like way. This is thanks in part to Gemini 2.5 Pro's context window, which allows it to hold a longer memory of the task, its environment, and past interactions, and this all leads to more coherent and adaptive behavior over time. Plus, the system can even handle commands that are abstract and infer unstated sub-goals, which is a huge leap forward towards making robots genuinely useful in dynamic, unpredictable human environments. But everything that I just mentioned hinges on ability number three, and that's understanding the environment. This isn't just about perceiving objects. Instead, it's about interpreting the spatial relationships, the affordances of objects, and the overall context of a scene. And Gemini Robotics ER 1.5 is particularly adept here. It uses visual and sensory processing to build a rich, dynamic mental model of its surroundings. And just consider a cluttered kitchen. A traditional robot might simply detect individual objects, but Gemini Robotics ER 1.5 can instead infer that a stack of plates is stable, that a knife is sharp, that a spilled liquid is messy and needs cleaning, or that a particular drawer contains utensils. And this deeper understanding allows it to make more informed decisions about how to interact with these elements safely and effectively. It can also distinguish between background clutter and task-relevant items. Plus, its ability to process long video sequences means that it can observe its environment over time, learning about typical object placements, human habits, and dynamic changes. And this temporal understanding is crucial for anticipating events and reacting appropriately. For instance, if it sees a person consistently placing keys in a specific bowl, it learns that this bowl is probably a key holder. And this level of contextual awareness is actually critical for enabling robots to operate autonomously in complex, human-centric spaces without the constant need of human supervision or extensive pre-mapping. So this is all about perception that leads to interpretation and interpretation that leads to intelligent action. But what good is an action that's wrong? That's where ability number two comes in, thinking before acting. In fact, this is now a core principle behind Gemini Robotics 1.5. Instead of directly translating perception into immediate action, the system employs a sophisticated reasoning process. When given a goal, it doesn't just grab the nearest object, it considers multiple possible action sequences, evaluates their potential outcomes, and then selects the most optimal path. And this thinking involves several key steps. Firstly, it generates a high-level plan, breaking down complex tasks into manageable sub-goals. Secondly, it simulates or imagines the results of these sub-goals using its internal model of the world to predict how its actions might change the environment. And if it needs to open a cabinet, for instance, it doesn't just blindly pull. Instead, it considers if there are obstacles, how much force is needed, and what the state of the cabinet door might be after its action. And it's specifically this predictive capability that reduces errors and improves efficiency. Thirdly, it can dynamically replan if the initial approach proves ineffective or if the environment changes unexpectedly. And it's this iterative planning and execution cycle specifically that enables the robot to work in unpredictable settings. For example, if it attempts to pick up an object that slips, it can immediately adjust its grip or try a different approach rather than repeating the same failed action again. And it's this thinking process fueled by Gemini 1.5 that allows these robots to move beyond simple automation into genuine cognitive performance in the physical world by acting intelligently, not just reactively. But a truly intelligent agent isn't confined to a single environment. It learns and adapts.
Which brings us to ability number 1.
In order for widespread deployment, Gemini Robotics 1.5 and ER 1.5 can learn across environments. And this isn't just about reprogramming for each new location, but instead it's about transferring learned skills and understanding from one setting to another. And the core of this capability lies in the model's ability to abstract general principles from specific experiences. If the robot learns how to grasp various types of objects in a factory setting, it doesn't need to relearn grasping fundamentals when moved to a home kitchen. Instead, it can apply its learned understanding of object properties, manipulation techniques, and physics to new yet analogous scenarios. And this transfer learning is significantly boosted by the large-scale multimodal pre-training of Gemini 1.5 Pro, and it's been exposed to all kinds of data from diverse sources, including videos of humans and robot interactions in countless environments. And this broad initial exposure gives it a powerful foundation for generalization. And what's more is that the system can continue to learn and refine its understanding through real-world interaction, which incrementally improves its performance as it encounters new variations and challenges. And this allows the robot to rapidly adapt to new situations with minimal additional training or human intervention. Essentially, every task in every new environment becomes an opportunity for the robot to become smarter and build a more robust and generalized intelligence. And this scalability of learning is exactly what makes these advances so promising for the future of robotics, and it moves us way closer to truly versatile, general physical agents. Now, according to this release, looking into the future, what should we expect from Google? Based on the trajectory, we're probably going to see Gemini Robotics 2.0 within the next 12 to 18 months, and it will probably involve multi-robot coordination. Think of a team of robots working together like a pit crew, each one understanding not just their own task, but also how it fits into the bigger picture. Plus, Google's been dropping hints about emotional intelligence integrations, so don't be surprised if these robots start reading body language and vocal tones to better understand human intentions. And here's the kicker. They're likely working on true real-time learning, meaning that these robots won't just transfer knowledge between environments, they'll probably grow smarter every single day that they're deployed. So 2026 may just be the ChatGPT moment for robotics, but tell me if you think that this is commercially viable or if it's going to take years to actually get to market. Anyways, like and subscribe, check out this video here, and thanks for watching. Bye.